In this lesson, we're going to be looking at solving one-step equations. And these are going to be one-step equations that involve either adding or subtracting. So let's look at this. The goal is always to get the variable by itself on one side of the equation. The equation is divided by the equal sign. So here's where the fence is. This is the dividing line. We want the variable to be on this side of the fence by itself. So that's the first thing you look for to see if the variable is by itself. When we look at this equation, we see that the x, or the variable, is not by itself. It has a plus 8 on the same side. So what we want to do is we want to move everything that's on the same side with the variable. So once I identify where the variable is, I look on this side. What do I need to move? I need to move the positive 8. Look at the sign in front of it. It's a positive 8. The opposite of a positive 8 is a negative 8. So that's our inverse operation that we're going to use. We're going to do the opposite. So a positive 8, the opposite is a negative 8. And to move it to the other side, what you do to one side, you must do to the other side. So if we do a negative 8 on both sides of the equation, well, a positive 8 and a negative 8, when you add opposites, it always becomes 0. And we call that canceling out. They're gone. It cancels out. And left on the other side, we have 30 minus 8, which is 22. So we know that the missing number, the variable right here, x, should be 22. And we can check that by plugging 22 back into the original equation. We're saying we think the missing number is 22. So we can plug it back into the original equation, which would have been 22 plus 8 is 22 plus 8, 30. Indeed, it is. So we say, yep, it checks. So we figured out what this missing number was, 22. Here we have x minus 13 equals a negative 45. Again, here is the equal sign. This is where the equation is divided into two parts. We look at the side with the variable. We see that there is a negative 13 on the same side. The opposite of a negative 13 is a positive 13. So we're going to add 13 to both sides. On the left side of the equation, when we add a positive 13 and we have a negative 13, they become 0. They go away. On the right side, we have different signs. We have a negative 45 and a positive 13 because we were adding 13. So we have to go back and remember what we learned about adding integers with different signs. Different signs subtract. Keep the sign of the one with the greatest absolute value. So here we're actually going to be subtracting the number with a larger absolute value minus the smaller one, which is a 32. But then we have to keep the sign of the one with the greatest absolute value. This is something we learned in previous videos. So a negative 45 and a positive 13 would be a negative 32. Following our different signs subtract, keep the sign of the one with the greatest absolute value. So what we're saying is we think the missing number right here is a negative 32. So we can check it by plugging it back in. What is negative 32 minus 13? Well, we have two negatives. We have a negative 32 and we have a negative 13, because if you were to add the opposite or do your click click, that would be a negative 13. So you can just see this and recognize that as a negative 13. Same signs, add and keep. 32 plus 13 is 45. Keep the sign would be negative. So it does check because it turns out to be a negative 45, which is what we wanted it to be. This is going to be the same thing that we do with decimals and fractions. So here we have the equal sign. Here's where the fence is. So we look over here on the right side. This time the variable is on the right side of the equation. But we want the variable by itself. So on the same side with the variable, we have a negative 9 7/10. So the opposite of a negative 9 7/10 would be a positive 9 7/10, which means we're going to add 9 7/10 to both sides of the equation. Of course, when you have a negative 9 7/10 and a positive, that becomes 0, so it cancels out. On the right side, we're just left with our unknown number. On the left side of the equation, we look at this. We have different signs. We have to remember different signs subtract. Keep the sign of the one with the greatest absolute value. So we take 13 and 9/10 and we subtract 9 and 7/10, which is going to give us 4 and 2/10. But the answer is going to be negative because 13 and 9/10 is the one with the greatest absolute value, so we keep its sign. Remember that rule that we've been working on. So we think the unknown number is a negative 4 and 2/10. We can check by plugging it back in. What is a negative 4 and 2/10 and a negative 9 and 7/10? Remember, if we add the opposite or do our click-click, both are negative. Same signs, add and keep. So we add them together, and that would be a negative 13 and 9/10, which does check. Okay, look for the equal sign. Here is the fence. We want the variable by itself. On the same side with the variable is a negative 54 hundredths. The opposite of a negative 54 hundredths would be a positive 54 hundredths. So we want to add a positive 54 hundredths to both sides of the equation. Of course, here on the right side, these are going to cancel out. On the left side, we have different signs subtract. We have a negative 6 and 5/10, which is the same thing as 50 hundredths, plus a 54 hundredths. So one is negative, one is positive. Different signs subtract. When we subtract 6 and 5/10, or 60 and 50 hundredths minus 54 hundredths, we get a negative 5 and 96 hundredths, because remember, we keep the sign of the one with the greatest absolute value. So we think the unknown number x is a negative 5 and 96 hundredths. So should I back up and show you the subtraction there? You can put a 0 placeholder there. We can regroup. 10 minus 4 is 6. We cannot go 4 minus 5, so we regroup. That becomes a 5. That becomes 14. 14 minus 5 is 9, and bring down the 5. If you didn't have a calculator for that. We think the unknown number is a negative 5 and 96 hundredths, so if we plug that back in to the right side of the equation where the variable was, that's a negative 5 and 96 hundredths and a negative 54 hundredths. Same signs, add and keep. So when we add those decimals, we always line up our decimals, and if we were to add it, we would get 6 and 50 hundredths, which is the same thing as 6 and 5/10, and of course it's negative, so it checks. Okay, here's the equal sign. Here's where the fence is. We want the variable, locate the variable. Is there anything on the same side with the variable? Yes, there is a positive 6 and 7/10. So we want to do a negative 6 and 7/10. Now you have to stop and think for a minute. It takes a little problem solving. We want to do a negative 6 and 7/10, but when I look at the right side, I see a positive 3 and 4/10. So right away I know that I have different signs, because I'm going to do a negative 6 and 7/10. So I know I have to subtract. When you subtract, you have to put the number with the greatest absolute value on top. 6 and 7/10 is farther from 0 than 3 and 4/10. So I actually need to take that one and subtract the smaller number, the number with the smaller absolute value, 3 and 4/10. So when I write it over there, I'm going to go ahead and put it on top because I know I have to subtract, and when I want to, I'm going to write this one on top as well to keep it consistent. Different signs subtract, so 7 minus 4 would be 3, and 6 minus 3 would be 3. Keep the sign of the one with the greatest absolute value, so that would be a negative 3 and 3/10. So you have to kind of behind your eyes looking ahead. You have to be thinking, remembering all the things that you've learned, and when I see that situation right there, I know when I have these two adding together that I have to put the one with the greatest absolute value on top in order to subtract. So something to be looking for. We think the unknown number is a negative 3 and 3/10. So if we plug it back in to the left side of the equation where the variable was, we have a negative and we have a positive. Different sides subtract. So we subtract with the one with the greatest absolute value on top, and that would be 3 and 4/10. which is what we wanted it to be, so it checks. We can do the same thing with fractions. Here's the equal sign, so here's the fence. We find the variable. We want to move the negative 2 1/3 to the other side. The opposite would be a positive 2 1/3, which means we want to add 2 1/3 to both sides. So now we're going to be adding fractions. Of course, a negative and a positive cancel out. Remember, with adding and subtracting fractions, you have to have a common denominator. We have the denominators of 8 and 3, so our common denominator would be 24. So we're going to rewrite these two fractions with a common denominator of 24. That would be 8 and 9 24ths because we had to multiply times 3. And that would be 2 and 8 24ths because we had to multiply both of these by 8. Now we can add them together and we would have 10 and 17 24ths. This is going to be from your assignment if you want to look at it for the day. Again, here's the equal sign where the fence is. Here's the variable, so we have to move the 13 to the other side. You have a positive 13, so we want to do a negative 13 on both sides of the equation, which gives us 75 minus 13, which is 62. Here's the second problem on your paper. Here's the equal sign. We find the variable and anything on the same side. We need to move the 4 7/10 to the other side by doing a negative 4 7/10 on both sides. So when we do a negative 4 7/10 on both sides of the equation, we have to regroup here. This becomes 8. 12 minus 7 is 5. 8 minus 4 is 4. Keep the sign of the one with the greatest absolute value, and we would have a positive 4 5/10. Here's one last example. We have to translate this first into an expression. Armando budgets $65 for his monthly cell phone bill. This is, when we see the word is, that's an equal sign. So $65 is 25 less than. We have learned that with the phrase less than, we know it's subtraction, but that this has to go at the end. So minus 25 is going to be at the end. His 25 less than his monthly savings deposit, but we don't know what the monthly savings deposit is. That's an unknown number. So instead of putting just a box for an unknown number, we put a variable there. We could use M for money. Write and solve an equation to find how much money he saves each month. His budget is $65. This is 25 less than his monthly savings. So we translated that into an equation. Now the variable is not by itself, it's being subtracted by 25. So we add 25 to both sides of the equation, and we find that he saves each month $90. So that is writing an equation and solving it. Good luck!